composite figures, which just means two figures or three figures put together. Okay, so this one again gives us a strange looking figure. So what we want to do is separate it into things we have a formula for. We have formulas for rectangles, triangles, trapezoids, kites, squares. And notice this figure, if we break it apart into this piece over here, is one of them. And then over here we have a triangle. We can do that because we know the formula for each of those. This is a trapezoid, and we studied the formula for the area of a trapezoid, and of course that's a triangle. So we're going to find the area of each of them separately, if I can spell it right, and then we'll add them together. So do you happen to remember the formula for the area of either a triangle or a trapezoid? Since we're going to have to do them both anyway. Okay, so the formula for the area of a trapezoid is the height times base 1 plus base 2, there are two bases, divided by 2. For a trapezoid, that's how you find the area. Now the bases are the two parallel sides, two sides going the same direction. So here's one base, and here is the other base. And this should say like maybe 8 feet instead of 16 feet. That's not possible. The height is the distance between the two bases. So this is our height for the trapezoid. Here's one base and here's the other. So I'm just going to go ahead and put those numbers in. So our height was 10.4. We had one base of length 8 and the other length 16. And that's all divided by 2. Now you have to go one step at a time and use the correct order of operations. So order of operations tell us to do whatever's in parentheses first. So that would mean adding the 8 and the 16. So then we have 10.4 times 24 divided by 2. Let's go ahead and do 10.4 times 24. That gives us 249.6, and then divide by 2. And we get 124.8 is the area of the trapezoid. Now let's find the area of the triangle. This triangle is going to be easier on us. It's 1/2 base times height is the formula, and we don't have to use the Pythagorean theorem at all. We already know that our base is 8 feet and our height is 10 feet. Now notice I did not use this side because it's slanted. The base and the height of a triangle have to make a right angle. That's how I know which ones to use. So I put those into my formula. I have 1/2 base times height. So the base is 8 and the height is 10. It gives me 80, and 1/2 of 80 is 40. Okay, so we found both areas. Now we can find the total area by adding those together. So we add the triangle, which was 40, to the trapezoid, which is 124.8, and we're good. It's 164.8. All right, do you have any questions on that? Awfully quiet. Okay, so again, we're still adding areas. So when you're adding areas, you take two figures, break this into two figures we can't find the area of, because we don't know how to find the area of a boot-shaped figure. But we do know how to find the area of a rectangle, and we do know how to find the area of a trapezoid. Okay, so those are our two figures. We have a rectangle on top, and then on the bottom there, we have a trapezoid. The other thing with this one is we are not going to get an answer with just numbers in it. We have x's and y's built into the problem. So that's going to make it a little more challenging, and our answer is going to look a little funny, but we can still do the problem. So let's first write down the formula for the area. For a rectangle, it's length times width. And for this rectangle, the length was 10 and the width was 8. We get 10 times 8 is 80. Right? The area of a trapezoid, again, like last time, is the height times base 1 plus base 2, all of that divided by 2. So let's put in the pieces that we know. Well, for one thing, this says it's a y, but if the height is 14 and this part of it is 8, 14 minus 8, okay, if we take out the rectangle part, that was 8. 14 minus 8 gives us 6. So I know my height right here is 6. Okay. The other thing I can see from looking at this is that this whole bottom was 24, but if we cut it off right here, we know that this is 10 for our x. So really we can really get rid of those x's and y's unless they want them in the answer. We put the information in. Our height of our trapezoid is 6. The bases are 10 and 24. And then we divide that by 2. Order of operations, so do parentheses first. 10 plus 24 is 34. And divide by 2. We get 204 divided by 2 is 102. So we have a rectangle with area of 80, a trapezoid with area of 102. We add those together, we have an area of 182. Right, here is yet another crazy figure. So this one, we have two figures here. We have half of a circle, and then we have a triangle. One problem we have is that in order to find the area of a circle, you have to know the radius, and we don't know the radius. The other problem is, to know the area of the triangle, we have to know the height, and we don't know the height. So the first thing we're going to have to do is use the Pythagorean theorem to find that missing side. So once again, here we go. We have a right triangle, so we're going to use the Pythagorean theorem to find something that's missing. So looking at the triangle, one of our legs is 6, and one of the legs we don't know. So I'm just going to leave A as A, and B is 6. The hypotenuse, C, is 10. If I square both, 6 times 6 is 36, and 10 times 10 is 100. Subtract 36 from both sides. I get 64, and then finally, to get rid of the square, you take the square root. Okay. So I get that my A, this side here, is a length of 8, and now I can do the rest of the problem. I'm going to erase that part of the screen, so if you want to put that down, let me know, and I'll stop for a second. If you're watching the recording, you can just pause the recording and write that down. I'm going to clear it out so that we can do the other problems. Okay, so we use the Pythagorean theorem to find that missing side. We again have two figures. We have a triangle and we have half of a circle. We're going to put those two together. Okay, so our triangle, again, the formula for the area of a triangle is 1/2 the base times the height. In this case, our base is 6, our height is 8. Again, you can't use the 10 as the height because it's a diagonal side. They have to make a right angle to be the base and the height. Okay, calculate that. We get the area of the triangle is 24. Okay, now we're going to work on that half circle. So we're going to work on a full circle and then we'll cut it in half. The formula for the area of a circle is pi times the radius squared. The radius of our circle all the way across is 8. The radius is just halfway across, which would be 4. Half of 8 is 4. So we're doing pi times 4 squared. 4 times 4 is 16. So we have 16 times pi, and just use the pi button on your calculator, or you can use the number 3.14. Whichever you use, you're going to get about 50.3, since we're rounding to the nearest 10. But notice we only have half of that circle. We don't have the other part over here, so we're going to divide that by 2. And that gives us 25.15. Now we can add our two figures together. Our triangle had an area of 24 square kilometers. Our half circle had an area of 25.2 if we round to the nearest tenth. And so we add those together, and the total area rounded to the nearest tenth is 49.2. If you have any questions at all, be sure and chime in here.